Okay, so let's begin with what statistics is. Does anyone know what statistics is? No one's had any statistics before, right? Great. So, Steve, I don't know your name. So what's your name?
Gabe. I just go by Gabe.
You go by Gabe. See, when I was asking, so you go by. Okay, so what do you think? So, what do you remember about what statistics is?
Evaluating sets of data and tables.
Evaluating what?
Sets of data.
Yeah, absolutely. Absolutely. So you have all this data. What do you mean by data, exactly? Not even exactly, just vaguely.
It's like results or like an outcome from something that occurred.
Yeah. Yeah, absolutely. Absolutely right. It's like raw information, right? It's raw information. The raw data, the numbers, the category listings, the indications, and so forth. So we can think of statistics as using mathematics to collect and analyze data. Another way to think about it too. So statistics, let's say, uses math to turn information into knowledge. I like that definition. I think that's kind of cute. What's the difference between information and knowledge? I want to guess what I mean by that between information and knowledge. How many students go to Montgomery County College? Roughly, how many?
10,000.
2,500? 2,500? That's more than that. I think it's like 50,000? I used to know this, when we first started it. I think it's much higher than that, because when we consider all the different campuses, because we consider like the evening classes and part-time, it was, yeah, that's what I thought, 60,000. 60,000 credit and non-credit students. 60,000. Okay. So here's your, let's imagine we have data on every student's height. So that means we have 60,000 pieces of information of height in inches. So what do we know? Is that useful? What do you mean?
That's information.
It's information. But is it knowledge?
No.
Yeah, so what would make it knowledge? Your name again was David. I should know that. I'll find it. That's how bad I am. Forget my own. What do you mean? Elaborate.
You just have a vague bunch of numbers. You use, take all the numbers. Maybe you want to find out the average of something, of the height.
Yeah. Immediately you took a step, right? You applied the mathematics. You didn't say, I'm going to take an average, which is a mathematical technique of adding everything up and then dividing by how many we have. And then now you have some number that tells you something about what's going on. And that teaches you something. Knowing the average height, that's kind of knowledge, right? That's information that's useful. But a bunch of information out there, a bunch of the raw information that's out there, that's not something that the human brain can really grasp in any meaningful way. It's like having a bunch of sales data every single day. You don't really know what's going on. Having the average sales data over the course of the year, oh, I can use that. That's knowledge. So statistics takes all of this raw information that we are generating, increasingly so in the information age, and then applies it in a way that's meaningful. Allows us to extract meaning from the raw data. In fact, we often say, not just analyze data, analyze sample data. That's what we talk about. Pulling an example is much more useful often than pulling everything that produced data. But it's more than that, too. Because statistics, the mathematics that we learn, the mathematics that we'll be using, allows us to work in situations where normally it's really hard to work in. And work with scenarios. Think back to high school. You most likely talked about a controlled experiment and the value of a controlled experiment, right? What's a controlled experiment? So many blank faces.
This is the base of your experiment. Goes around.
Tell me more. What do you mean?
Like, if you're, I guess, it's whatever you find in your experiment, you base your research off what you did as like your base, your starting point, basically.
It's sort of like a point of comparison.
Yeah.
Yeah. So could you give me an example? Anyone give me an example of a controlled experiment? Yeah.
I guess with the Patriots and the Playgate, you get a football from the game before it started, and then later on after at halftime, I guess when they measured how much air was in the ball, that would be the control would be the ball before the game, and then they compare it to the ball at halftime.
So yeah, so for those of you who don't know, which is honestly myself, what is Inflategate?
It was that. It's like 3 years ago.
Something sounds very familiar.
The Patriots were playing the Colts, and it was like the footballs were deflated supposedly, and like it was cheating.
Is that like you can kick it farther or something?
Nah, it's
Or
like
not as far.
You could get more grip on the ball.
Oh, okay.
Yeah.
Oh, that makes sense. Yeah.
But another example, all of us are scientists in the world, all of us the same exercise, the same farming in order to exercise.
Mm-hmm. Yeah, but we need some sort of something to compare it to, because we don't necessarily know. So we'll get to that example in a moment. We'll start with the basic idea, though. We'll take the football and how much of a difference does it make, the grip or how far you kick it or whatever it is. I don't know how to measure grip. I guess I don't know how they would do that. This is a hard example. PSI. But that's just checking to see, because the question was, does it deflate? Does the deflation matter, or was it deflated? Was it deflated? Oh, okay, that's easy to measure. Never mind. Yeah, because you use PSI. Yeah. So you can have the football before, and then put it under the rigors of what it would be like in the first half of the game, and then check again. And then that's a control experiment. You have a base, the control, before it's set to the rigors of the experiment and of the game, and then after you have the treatment. Right? And you can see if there's a difference between the two. How many times did they do that, though?
Oh, they measured like 12 Patriots balls and then 4 Colts balls, and they were different between the teams.
Ah.
Yeah.
So notably, they didn't just do it once. Why didn't they just do it one ball over here or one ball over here? let's do this. Let's imagine you wanted to know. When I was a kid, I did this I did a science experiment where I wanted to see if putting vitamins in the soil would help the beans grow. So, you measure how long the beans are. And so I had a control where there were no beans, no vitamins in with the beans. And then I had like a treatment where I think it was like put like vitamin C, and then I also had like B12. I had a bunch of different vitamins. Do you think I just did this with, there's one plant with no vitamins, and there's another plant with vitamin C? No.
It's not enough information.
That's not enough, exactly. What do you mean? Well, if I were to only do two,
It's not enough to come to a conclusion that there was like a difference.
why not? Why would only one for each? Or do you not? Why not?
We need more to get a better, more exact.
Why? If I found out that one was longer than the other, can I be like, okay, right? It makes a difference. I mean, you're right. I'm wrong if I did just one, but I want to know why.
Then it's not a big enough like sample of data.
Okay.
You know,
Yeah. Why is that not enough, though?
it could be one of them could be an outlier, and it could be the same data. If you had more, then it's like you would have something that definitely would not be an outlier.
Mm-hmm. Yeah, even though I set a control experiment, I'm keeping everything the same, the only difference is the vitamins. Maybe the genes of this one are a little different, and it just grows a little longer naturally. Or maybe slightly off on how much water I gave it, or maybe the soil is slightly different, or the light was slightly, even things you can't control. And so you need multiple observations in each one. That's why they check multiple walls, right? Maybe there's some difference that we couldn't account for. That even though we're controlling everything, maybe it's not. And statistics can teach us, is this difference based on the sample size, is this difference likely to be a genuine difference, or is it likely to be random? So that's one thing statistics can help teach us, is analyze this information. Are these two things that's going on, are they really different or are they not? But even if we're not in a pure, clean scenario, this really great scenario of a controlled experiment where everything's over here and everything's over here, we keep them separate, but they're identical except for the one treatment that we're doing to it, we often can't do that, especially in the social sciences. So I can't remember your name. Was it you who were bringing up the example?
Joyce.
Joyce. What was the example you wanted to bring up?
There were scientists running around and there were experiments and all of us on how we would react to that one experiment.
Mm-hmm.
And there would be another one where we would experiment another group of different ones to have each one would react or something.
Yeah. And so even then, here they're running this experiment. And now it's a little harder to control things because you have limits on how many people you can bring in. You might not be able to control the environment as much as you can, right? So that is a pretty good example. I was thinking of something else when you were mentioning that, but that's a pretty good example of a controlled experiment. In the real world, though, we often have even more constraints. Is the minimum wage something that if you increase the minimum wage, what effect will that have on unemployment? Will people who make the minimum wage be better off? Will they be worse off? Worse. Maybe. Right? I mean, I'm an economist. I'm sort of sympathetic to maybe they'll be worse off if you force wages higher. But you can tell some people will be better off, right? They won't get fired. So how would you test that? You can't be like, I'm going to have two identical cities, and in one city I'll increase the minimum wage, and the other one I won't, right? You can't do that, right? You can't have two identical cities. So how would you test it? I mean, but that's the theory. How do you get the empirics? How do you get the data to suggest the drop? Sure. So you can be like, so one thing too. What's great about the United States, what's annoying about the United States, is that different states have different rules. So rather than going to different countries, right? Well, the circumstances in different countries can be very different from one another. You can say, well, in this state, they increase the minimum wage, and in this neighboring state that they're not, let's look at city that's right on the border and see if one half of the city changed and half the city didn't, right? And that can be your control, essentially. But that has issues, that's tricky because the culture could be different across the states. Other rules could be different. There could be long-term impacts. Other things are changing at that time. That's true, and so that can give us some of that information, but then there could be biases in that as well, that other things are happening across that same point in time. Or, like if you're saying, what's the unemployment rate now? What's the unemployment rate 10 years ago? Before the minimum wage increase? Well, lots changed. Other things have changed too, besides the minimum wage change. So I'm not saying that this is not something that can't be figured out. I'm saying it's the realities and constraints of the world make it harder to get any definitive answers. But that's where the statistics becomes very valuable, is they give us more tools to help sort of parse out some of these little corner cases to try to quantify exactly how much of this is a genuine change and how much of this is just random or due to something else. So we're going to be dipping our toe into some of these ways that we analyze the data and understand what's going on. But in order to fully do that, we're going to have to get some kind of terminology down. For one, as a side note, never say this. Never say data is. Or if you want, the data is. No, don't say that. Don't do that. You know what you're supposed to say instead? The data are. Say the data are. Why is that?
It's more broad, maybe? More broad?
More grammatical. What's your name again?
Aziz.
Aziz?
Technically the data, basically, the data itself doesn't represent something, but it's, it itself isn't what we're looking at, but it kind of shows what
I mean, you're right. It's sort of showing us like something larger than what we're seeing, but all I did was change it from is to are, and I did that because data is plural. So this is, I tell this to you, like, why did you spend my 5 minutes telling us this? Because when you're talking to other statisticians and you're talking to other people who know what they're talking about, and you make simple little mistakes like saying the data is, they will think you don't know what you're talking about. So just as a side note, get used to thinking in terms of the data is plural. Data is plural. What's it plural of? What's the singular? Does anyone know? No, that would be cheap. No, then we wouldn't have to do this. Data is plural of data. I don't just pronounce datum or datum. No one ever uses this word. But a datum is a single piece of information, like the height of one person at Montgomery College. But we never work with just like that one, right? That's not enough information to really draw anything. We work with data. Lots of pieces of information. So that's why you never really hear of data. Or data. You hear of data. The data are. Okay, let's do a little bit more. So, there are 3 pieces of terminology elements. We had element first, and then went full variable observation on that. Variable and observation. And to help illustrate the difference between these 3 things, I will give you an example. So this Apple, Microsoft, Walmart, and I'll have stock price. Industry. Apple is consumer electronics. Microsoft is software. And Walmart is retail. And the stock prices that I have are $103.13. Microsoft's stock price was $55.22. Walmart was $62.86. And this is as of January 5th, 2016 at 5:55 p.m. So, I imagine you have heard of the term variable before. How many of you have heard the term variable before? Great. How many of you have heard the term observation before? Excellent. How many of you have heard the term element before? Oh, I mean, but like outside of the science class. Like I'm not talking about element like helium.
Elements. Outside elements.
Like an element in terms of the statistics. Like they would know, I don't think this is not a word that people know in the context of a statistics course. I'm assuming that's the case. Okay, it's fine. That's the one that people can always forget about. So, can you identify the variable or variables? Stock price. Stock price is a variable. Excellent. Another variable. Are there any other variables? Industry. Excellent. Industry is a variable. Marine. Who said stock price? David? Yes, okay. And what's observations?
Stock price.
Stock price is a variable.
So,
It's observations. These are our observations. Apple, Microsoft, Walmart. Stock price. How did you know that these are observations and these are variables? How did you know that?
Because that's what you're observing, the company.
Okay. What do you mean? Tell me more.
Like the different companies, they are the things that you're actually watching and trying to get data from.
Yeah, these are the things, right? In other words, like the thing that these two things have in common, the 103 and the consumer electronics, is Apple.
Yeah.
Right, exactly. So, what do you suppose the element is? Well, let me actually give you the definition of what element is. It says. On what data are so what is the element in this table? Company. Exactly. So that's sort of your starting point. You pick the element, right? Earlier, when we were doing the students at Montgomery College, students would have been our element. We're getting data on the students, whether the height, maybe the GPA, maybe we're throwing their major, long step list of stuff. The variable is a notable characteristic about the element. We're curious about the stock price of various companies. We're curious about what kind of industry various companies are in. Observation is a particular element. Microsoft is a particular company. Walmart is a particular company. Any questions? We can further think about data by noting that there is a clear distinction between stock price and industry. But these are clearly not the same kind of data. Why is that? What's the difference between stock price and industry? Stock price can change, that's true. Industry can change too. Think more fundamentally. One's text and one is digits. In other words, one is categorical, it's various categories throughout, and one is numerical, or what we call quantitative. Quantitative data is made up of numbers, numerical values. And there are clear implications between observations. For example, Microsoft's stock price is roughly half of Apple's stock price. It's roughly half. We could also, if we want to take an average stock price, because it's all numbers. If we think about categorical data, it's made up of categories. It's a terrible definition, but the word categories is very useful. And inferences between observations doesn't mean anything. I mean, it's one thing to say, oh, Microsoft is in a different category than Apple, but we would never say software is half the value of consumer electronics. As we would say, 55 is about half the value of 103, roughly half the value. We would never say this is half. That doesn't make any sense. If our element is students, what would be a good example of a quantitative variable? Height.
Ages.
I did height though. Ages. I like ages. It's Ike, right?
Yeah,
Ike. What was that? GPA. Your name is Gabe. I was just seeing you with that. Excellent. GPA. What would be a good example of categorical data if our element is students? Majors.
Names.
Fantastic.
Names.
Names. Yeah, I suppose, yeah. Wow, that's going to be a lot of categories for that. But yeah, absolutely.
Would birthdays be categorical or numerical? Because it's a number, but it's
I'm glad you brought that up. So, what's important is that, like, while I do this thing with, oh, this is made up of numerical values, this is made up of categories, the whole point is what it matters as far as, like, comparisons. So, you would never say that, like, oh, being born on February 1st is twice as good as being born on January 1st, right? Because they're like, one is the second month and one is the first, right? So, like, while you can express as a number, I see that as more kind of a category, especially too if you put it into what's it called? Months as well. You can say the first month, second month, third month. It depends on what you're sort of looking at, like, and how you're using the data. Because you can also express it in terms of how many days in the year you were born, and maybe what you're curious about matters for that. So there's a little bit of give there, right? And it's the same thing too with grades. Like, in some ways, a grade is categorical data, because A, B, C, they're in categories. But you know, it's not unreasonable to say that a C is half as good as an A in some kind of way, because one is worth a 2 for your GPA, and one is worth a 4 for your GPA. You can convert them to numbers. So there's a little bit of some give there, a little bit of a gray area. And birthday is an interesting case. Any other categoricals for students?
Language spoken, how many languages do you speak?
Oh, how many languages they speak kind of sounds like quantitative, right?
Oh.
Right. But if you want to say which languages they speak, right, that would be categorical. Yeah. Gender. Gender classic category. Right, their gender identity. Ethnicity. That's what I was saying, the national origin as well. Right. Absolutely. So you can think of there's lots of different variables on both sides. Any questions? Yeah.
On that last sentence, the emphasis between the observation, what is that word?
Oh, are meaningless. Are meaningless. Yeah. Thank you for bringing that up. If you can't read my handwriting, please let me know. I don't like to rely too much on PowerPoint because I'm afraid I'll go too quickly. And I think that students like me to suffer with them when I'm writing things down. Am I right on that?
Yes.
Like yeah. I love how quick they're like, yeah. So I like to write things out, but of course sometimes that means you can't read my words. So thank you for. Okay. Let's do another one. Elements can be put into two different categories. Cross-sectional or time series. Cross-sectional or time series. In a time series data, the element is time. In this particular year, these are the various things that will happen. And in this other year, these are the various things that happen. Like each individual observation is a year or a day or a month or a week or an hour. Observations are particular points in time. And variables are essentially different kind of objects of interest. They could be anything. They could be, companies' average stock price, or number of potatoes eaten per person. They could be anything. Cross-sectional, the element really could be anything, save time. And all observations for all variables reflect roughly the same point in time. That's why I mentioned here, all these stock prices were gathered at the same time. And by the way, this was an industry too, at this time, and day, and then month, and then year, and so forth. As noted, of course, industry doesn't change that often, but it can. It can. In other words, in a cross-sectional data, you're picking a particular point in time and you're comparing lots of different things. The element could be, this is how your memo is set up too, your memo data. There's one data set where the element are US states, we call it state level data. And so every observation is a different state. And then the variables are different things about that state at roughly the same time. Sometimes data constraints prevent us from having everything at exactly the same time. So that's why I say roughly, because it's close enough. Like, they're all, I think, 2012, and some stuff is maybe 2010, and some stuff is maybe 2016. Like, I think I have, I just put in election data for 2016 in there. And I'm like, well, if you want to do an analysis with election data 2016, and you want to do it with, like, some data from, like, 2014, you can do that. That's not a huge deal. Those are close enough. It's hard to imagine that things are going to radically change in 2 years so that to render your analysis worthless. If you were to try to do that with 2016 election data and 1950 income data, well, that's just stupid. What are you doing? That's way too different. So that's why I say roughly to give yourself a little give. I don't want people to get too hung up on that. I also have data too on another thing in your memo data set, our country level data. Countries all over the world. And then I have lots of variables about like alcohol consumption or GDP or latitude, where the country's latitude is, roughly where it is in the world. But that's all gathered to roughly the same time in a particular year. I think it's 2005 is the year that happened probably. Again, a little gift. Any questions? So, that's what I have planned for today. What I would like to do is us to get a head start on what we'll be talking about on Thursday. We have like 10 minutes of class, and we can just get started on working a little bit with this stuff. As mentioned, most of you already have a good knowledge of this. So, I think this will go by relatively quickly. Again, I don't want to go by too quickly because CMAP 120 is not a prerequisite for this course. So I don't want anyone to get the impression that, oh, I have to master Excel before I can take this course. That is not the case at all. But in the interest of time and using things efficiently, and maybe go a little faster than I normally would. If you are having trouble too, you should come on my office hours, and I'm happy to fill in any gaps that you might have. But we're still going to go over the basics, even if you already know it. I help. I don't waste people's too much time. It's always good to get a refresher. I've also discovered too, I can't sit in that chair. I gotta sit in this one because otherwise I'm like blocking people's views. Okay. Whenever I am looking to do something with Excel, and this is kind of a bad habit I have, come to think of it, because I have a lot of these files open on my computer or like on my desktop, is what I do is I right click, and I hit press new, and you can see I can make a new Microsoft Excel worksheet. I said I probably do this too much. I got like tons of these, so I have no idea which one is, because they always like, if you make a new one, it just says, oh, okay, so this is now like 1 or 2 or whatever it is. So I have no idea what's going on with my stuff. But I don't know. But we're going to double click it just to give us something to work with. If you've never used Excel before, it's a spreadsheet program. Right here we have rows, 1 all the way to, I can't remember how high I go. It's limited by some sort of information it has in its system. I don't know, it's a really high number, in the tens of thousands, I think. And then columns are indicated with letters, and they don't stop at 26. When you get to column 27, what is it called? Column 27, do you remember? Yeah, it's called AA. And then we go A, B, A, C, A, D, so it can actually get pretty far as the columns too. There's a lot of space here. But we're not going to work with very much of it, so we're going to zoom in. I can zoom in by pressing and holding Control and then moving the mouse wheel back and forth. But you could also use this right here. This is annoying. Because you got to drag the mouse holding up and click the button. Right? It's much more fun to use the press and hold Control and then move the mouse wheel. If you click a cell, you highlight that cell, and you can start typing stuff in the cell if you want. You can also double click the cell and it makes a cursor. That allows you to edit things that you would type too. Okay. So I can add in the right there. But if I click it once and start typing, I just type right over. So don't mix those two up. But that's not really what we use Excel for. I mean, you can do that for word processing. That's weird. Don't do that. What's more fun is to use the numbers. So I'm going to add, well, let's say 5, 2, 6. Let's say 5, 2, 6. But let's imagine I want that not to be $526. I want it to be $526. What do I do to make that happen? So there's a couple things here. You can go to so you can format the cell, which takes too long. No. Time is such a scarce resource, right? You can go to the number section, and then as you point out, you just hit that $sign there, and it will immediately not only add a $sign, but it will give you a decimal with 2 places after it. Sense. And note too, it changed it from general to accounting. You can also, if you want, change it from accounting to currency. I don't really know, excuse me, I don't really know what the difference is between those. In practice, like, I know that the $sign is to the left more, and this has sort of been like shifted over. I don't really know much beyond that. I'm not an accountant, so they have some weird way of doing things, and Excel likes it that way. You can do currency, you can do accounting, you can do number if you want, get rid of that $sign. Well, let's just stick with currency and put stuff. If you want to type in 20%, how would you do it? Yeah, so I typed in 20. How do I make that a percent? Do that then. So let's press the percent sign. What do you get? You got 2,000%. What happened?
It added 2 zeros.
Let's do that. There it is. Absolutely right. So Excel knows that percent means out of 100. So it will multiply the values by 100. Specifically 100% when you convert it. And indeed, if you change the format from percent to general, it makes it 0.2. There's a couple of sales, accounting, currency. Let's imagine I want to do. Here we go. Here is. What was that? So I wanted to type in 23.562%, so I put in 0.23562, and then I want to make it a percent, and I hit the percent button, and I got 24. What happened? It rounded. So how do I get into display the decimals I want to display? I want to say 23.5%. What do I do? Right here. These two, yeah, exactly. So CJ notes that these are the buttons we can use to give us more or fewer decimal places. So I want to add some increase the decimal, so let's put it down here. I can get all of them. And now if we keep going, we're just going to make them zeros. I don't want to do that. I'm going to do it too. Is anyone curious? What is 23.562% of 526? Mathematically, what is that? I'm gonna delete this right here. And I'm just actually gonna delete all of row 2. Just delete all of row 2. What is 23.562%? 526. How'd you find that? When you do that on a calculator?
I did it on sum.
You summed it?
The sum multiplication. So it's like equal.
Yeah, that's what I was waiting for. Yeah. Equal. So those of you who had seen that before know the secret to Excel is that right there. I love the equal button because the equal button, as we'll discuss, also unlocks the function option. I'm running out of time. But it also allows you to, when you hit the equal, that means it will not show what you type, it will show the result of what you type. So if we hit equal and then make a cell reference, A1, by clicking A1 once, don't click it twice, don't double click it. That's the most annoying thing that really, screws you up. Then you hit the star button for multiplication, and then hit A2, and then you hit enter. 123.92, whatever that is. And what's cool too is that if you change these numbers, you change the result. That's pretty fun. If we had this set up, that's the dollar, and that's the percent. What if I wanted to find this, 259 and 30%? Do I have to type in B1 times B2? B equals B1 times B2? What's a faster way? Click on this. So, what's a faster way? You just click that little box. So there's two ways to do it. One, if where you're going is really close to where you were, you can grab that little box and drag it, and it will essentially copy and paste. Until you see that little plus sign there that you see, plus sign, copy and paste. Boom, there it is. You can also, of course, just actually Control C and Control V, just in case they're right next to each other. They're not right next to each other. If I press Control X for cut, and I paste it right here, what will happen? What happens? Excel is smart. If you are copying and pasting, it says, oh, you want to do exactly what you were doing before, but just in a different place. So it will update your cell references. Note this one references B1, B2 rather than A1, A2 because I moved it one column over. But if you are cutting and pasting, it knows, oh, you just want to do the same thing but somewhere else. You're reorganizing. And so when I cut and pasted, the cell references did not change. And you can see both of this if you hit Control tilde, which is the number right next to the 1, to show formulas. I know I'm out of time, but I'm just going to cut and paste. And I'm going to ask you one last thing. What are these two numbers added together? Know how you do that? Or you can do sum, which is useful if you have like 80 numbers you want to add together. So Excel also has, as we'll discover over the course of the semester, a lot of functions built into it, a lot of equations built into it. Sum means you're going to highlight these two things, and it will just add everything that you've highlighted. A3, colon, indicates a separator to B3. So it draws a box with this number as the upper left-hand corner, this number is the lower right-hand corner. We press enter, and we get the sum of these two things. And so that's a lot easier. You just highlight a whole bunch of things if you want to add like a whole bunch of numbers together. Does this seem familiar to a lot of people? Or maybe not. We'll talk more about it on Thursday. I'm out of time. Have a great couple of days, everyone. I will see you in 2 days. You too.